Alright, we then jump to number 3. Number 3 says compare the two graphs shown below and answer the two questions below. Part A says name 3 ordered pairs that are in the solution represented for graph A. So we're looking for things that work for A, but not, again keyword here, it's even in all caps, but not in the solution set for graph B. So we don't want them to work for B. And of course B is like all the way down here. I'll just go to write it over here. So we want graph A to work, but not B. Now before we can decide, okay, graph A works, B doesn't work, we have to just figure out where our solutions are for each. And with this I can kind of use a marker or something a little bit bolder to show you guys. So whenever we're solving something like this, we have to make sure that we are looking and understanding where our solutions is. So for graph A, we have one line, and so we have one shading. I'll remind you guys that when we're looking at graphing and shading, if it's a bold line, that means it works. So my solution would be on the bold line. And my solution is also in the shaded part, so it would also enclose all of this. And of course this line would keep going, so this space would forever extend. Right, but my shading, or my part where my solutions can be, is going to be this entire space right here. Alright, so there's where my solutions are for the first one. For the second one, we have to be a little bit more clever. Now right now it looks like it's the exact same shade for all 3 of those options. But for a fact, we know that my shading, or my solutions, are not going to be in the non-shaded part. So we know for a fact that part's out. We just have to figure out which one of these 3 parts actually needs to be darker. The way that I would do that is, of course, I would just kind of break it down one at a time. So this line right here looks like it's shaded up, looks like it's shaded this way. So I know that this section and this section get shaded once. Right, so technically this part gets shaded once, this part gets shaded once. Then I look at my second line. My second line is this one that's going across, and then this one is shaded up, looks like. Right, that would be the shading for that one. So then this one gets shaded once, and then lo and behold, this part here also gets shaded again. It gets shaded twice. The one that gets shaded twice is the one that's our solution. So this time, and again, we have bold lines, so the lines are also part of my solution. So these lines are part of my solution. So if points landed on those lines, they would also count. And then of course everything in the technically double shaded, even though it doesn't look double shaded, this part here would be my solution. Alright, so now we figured out our 2 solutions. So we're trying to figure out something that works for this one, that is A-okay for that one, but does not work for the solution set on this one. And the way that we would solve this is pretty simple. If you look at this, if you look from one to the other, if I was somehow able to fold these one on top of the other, we would see that that shape right here is kind of like what gets made. Maybe not as, I'm not as accurate, but you know, that shape right here, maybe I can draw a little bit more accurately, something like that. That's where the solution is. So really what I'm looking at is I'm looking for points that fall in this area, because that area would work for this one, right, which is what we want, work for A, but wouldn't work for this, right, that doesn't land in the shaded part, doesn't work for B. So really any points that fall in here, just to give you guys a few examples, I won't write all 3, that way you guys can kind of practice or write your own. But let's say, for example, I'm going to go to the extreme and I'm going to go say positive 10, negative 10. I'm going to get one all the way down here in the corner. That point would work for this one, but not for that one. Right, so the point 10, negative 10 would work. Another point that would work maybe, just to give you guys one more, is positive 5, negative 4. Something like that. One that kind of lands in the middle. And again, positive 5, negative 4 would be right there. And of course that's not in the double shaded, but it works for this one, doesn't work for that one. So again, something like that. Part B says name 3 ordered pairs that are in solution for system of graph B. Again, graph B is this one, and so really you're just naming any points that fall in here. Points like, in this case, positive 10, positive 10. Therefore, again, we're looking at the extremes of the corners. Or something like 5, positive, I don't know, 8. Something like that. Of course, there's quite a few numbers that you can choose from. So you kind of just have to go through and make your decision. All right, number 4 says, Cindy graphed the system of equations below. She was asked to give her best estimate of the solutions by looking at the graph. Her answer is below. Do you think she found the best estimate? If not, correct her solution. All right, so this one brings us back to, and of course people, today in class were saying, well, there's no equation, there's no, how am I supposed to know where the solution is? There's no shading, how am I supposed to know where the solution is? Remember that we look at 2 different types of systems, and systems just means 2 lines. First type of systems that we have, or first type of system that we looked at was the one with shading, so we looked at the double shading. The second type of system that we looked at was just 2 lines, and whenever we have just 2 regular lines, our solution to that system is going to be where those 2 lines meet, or where those 2 lines cross. So in this case, it's going to be right there, and their estimate was 2.3, 2.8. And so we're just checking to see if their estimation works, and if not, we're just going to correct their estimate. Now, if we graph this point, of course, it kind of throws you off because you want it to be on that. But if we graph this point as is, we would go over 2 and a 0.3 somewhere in here, right? And then we would go up 2.8, so up 2 boxes and a little bit under. So we're somewhere right there, which of course isn't where the 2 lines meet. So already I know that this solution is not correct. Now to figure out the solution that actually is correct, looks like 2.3 is a pretty good estimate as to how far we have to go. But this time we have to go down 1 box, 2 box, and a little bit of the other box. All of today I've had students say something like 2.3, negative 2.8, and something like that I would be able to take, or I would accept. On the test, all you have to do is be able to kind of like find a point that crosses in between the 2, and then just be able to estimate kind of where it would be. So you just have to be okay with using some decimals and figuring out where kind of that point would fall. All right, we can then move over to 5. Problem number 5 says, write the system of equations that are graphed below. So all of today I've had students just give me the point of where this crosses. Make sure that you guys are reading. This says write the system of equations, which means write the 2 equations that are listed, or the 2 equations that are graphed. And of course, when we write equations, we want to write them as y equals. So I'm going to write 2 equations. It doesn't matter where you start. You can start wherever you want. I'm going to start with this bottom one, and then we'll kind of work from there. All right, so this bottom equation, I'm going to kind of start at the back. Of course, we're still using y equals mx plus b. We're still using this equation. Just because of the way that I graph it, I would start with the b and then go to my slope in the end. So I'm going to start with b, so I'm going to kind of leave a little bit of space and then write out my b. So my b for the first one, my y-intercept looks like it's going to be at -4, so I'm going to leave a little bit of space, and I'm going to go and write my b, which is -4, or -4. Then we check our slope. Our slope, of course, is rise over run. I'm just going to shorthand that to r over r. And then we just basically check how far up or down do we go, and then which way. So it looks like if I go down 1 over 2, down 1 over 2, down 1 over 2, it looks like if I just keep that pattern going, I would recreate the line that's already given to me. So it looks like my pattern is down 1 over 2, which down 1 would be a -1, and then to the right 2 would be a +2. So it looks like my slope or my rise over run would be a -1/2. So I can type that in as -1/2 x. And then my second equation, we do the exact same thing. We look at our y-intercept first. This time looks like my y-intercept is at -1. Then my slope looks like we go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So it looks like if my rise over run for this one would be down 2 or -2 over +1. And then these you always want to try to type them into your calculator, see if they reduce, because -2 over 1 is going to reduce to just regular -2. So this one would be -2x. So my 2 equations, or my system, would be -1/2 x minus 4 and -2x minus 1. Part 6 says, some of the values from the 2 linear equations are shown in the tables below. What is the solution to the system of equations represented by these tables? So with this, we're basically looking at like our equations, or looking at our table. Now when we did this in class, we always try to match y1 and y2, which we would, and we'll talk about this problem in a little bit. The table up here is just a different representation of the exact same thing. What we're trying to do is we're trying to match a combo of x and y that shows up in this table and it shows up in this table. And really, once you work a problem like this, after you work it, the rest of these seem pretty easy. The problem here, or the solution here, is going to be that 0.37. 37 is the only point that shows up in both tables. Right, no other point, -1,3 doesn't show up here, 5,9 doesn't show up here, 7,11 doesn't show up here. The only point that shows up twice is that 0.37, so my solution here would be the 0.37. Right, and like I said, once you work one of these, you're like, oh, these are super easy. All right, number 7 says, the table shows the ordered pairs from two functions which make up a system of equations. Write the solution of the system of equations and find the equations that are represented in the table for each function. All right, so when we look at a table like this that's all together has 3 columns, now we're looking for where y1 and y2 are the same. So as we scroll down, we just look at where they're the same. Hey, they're the same there. Right, if they're the same there, then we highlight the entire point. So we would look at this whole thing. And of course, my solution is not going to be 2, 2, because if I go up, that would be y, y, and my point is never y, y. My point is always x, y. So x and then one of these 2 y's, which luckily the 2 y's are the exact same, so my solution here would be the 0.62. And of course, how do you know? You would write something like, the y1, y2 match, so I get my x value and my y value. My x value is 6, my y value is 2. Alright, part 8 says, Mike is buying music online to download. He is considering 2 different online companies. Music R Us charges $1 for each song downloaded plus a $10 membership fee. Downloads R Us charges $1.5 for each song downloaded plus an $8 membership fee. Define the variables for the situation. Write the appropriate system. What is the solution to the situation? And what does the solution mean in a complete sentence? Even though they give you these part A first, I oftentimes see that writing the equations first kind of helps some of my students, so let's go ahead and do the equation first. In this particular instance, the equation, again for music R Us, the very first one. So both of your equations are going to be y equals. First one, and I always tell my students to circle the dollar amount, so we have $1 and then we have $10. And then we just have to figure out which one of these has the x. In this case, we have $1 for each song, so in this case that for each song tells me that that's going to be x. And then plus the $10 membership fee. Usually you only pay a membership fee once. So the equation for the first one would be 1x plus 10. For the second one, Downloads R Us charges $1.50 for each song. So once again, that's the x plus an $8 membership fee. So this one would be 1.5x plus 8. Alright, so there are my 2 equations. Now from here I can kind of try to piece this together, try to figure out what x would represent, what y would represent. So I already kind of know what x represents because of this. It says x represents for each song, so x technically represents the number of songs downloaded. And then my y. Now with y, sometimes you kind of have to think about it. In this case, we're talking about money. Usually when you're talking about money, your y is going to represent your total cost. Again, not always, but I would say maybe 90-something percent, 95% of the time, it's going to be total cost. Again, because the membership fee plus the songs that I download, depending on how many songs, gives me my y value of how much money I would spend. Alright, next it says, what is the solution to the situation? With solution, you would basically go through, type this into your calculator, and solve. So I have my calculator right here. Since they're both in y equals, we're going to go to y equals, and we're going to type in both equations. So first one we have is 1x plus 10, or in other words, just x plus 10. Second equation is going to be 1.5x plus 8. Alright, so there are my 2 equations. I would hit second graph, and then just like the previous problem, I just look at where the tables are match, where the tables are even. I don't know why mine starts all the way down here, but I basically scroll up until I see where they match. What would be the negatives? Oh, there it is, I missed it. So here they match y1, y2, 14, and 14, which means that my point is 4, 14. So my solution for the situation would be 4, 14. And part D says, in a complete sentence, write what your solution means. Well, basically, we look back at what x represents, what y represents. In a sentence, basically, you would say, if we download 4 songs, my total cost would be $14. So something like cost $14 for both companies. Something like that. I guess it's a good time to stop this video, and then I think we have one more video, or maybe possibly 2 more videos.